Hello, everyone. Welcome to our webinar. I have just clicked on the record button, so we will be recording this session. And in case you miss something, you can join our YouTube channel, or you can listen to it on Spotify podcast as well. My name is Birden, and I will be the presenter for today. Let me turn on my presentation. I will go through a presentation, and then there will be a question and answering session at the end. So you can shoot your questions from the chat box, and I will be able to answer them. So the name of our webinar is Cause and Effects. I will explain this title actually after a while, after I introduce myself. But we're going to be talking about how can we manage our processes faster with AI solutions. Well, I've been working on total quality management and operational excellence since 2000. I have actually over 20,000 hours of training experience, but I put this 10,000 because of the infamous book of Malcolm Gladwell, The Outliers. Currently, I am living in Turkey, but I've been doing consultancy businesses for different countries, not only Turkey, for different industry sectors and service industries as well. I have founded the company named Bilik OPEX. I'm the co-founder, and currently I have 4 scientific articles about digitalization. And also, I'm currently the board member of Turkish Informatics Society of Istanbul branch as well. Let me give you a quick brief about our organization as well. Bilik OPEX has been founded in 2015 in the UK. And then we have started our business also in Turkey. And currently, we have branches in Saudi Arabia as a joint venture and also in Germany as well. What we do is we are a different kind of operational excellence company. Actually, we call ourselves a digital operational excellence company. The reason I'm saying this is we not only use Lean Six Sigma as an improvement methodology, but also we use different digital solutions, digital tools as well, which I will be presenting 2 of them today. As you can see, we are resided in 2 different locations, but as you can imagine, maybe some of you are also consultants. You don't need a location to be able to do the consultant business. So I've been in the Philippines, in Oman, in Bulgaria, and also different countries as a consultant as well in the past. And our main aim is to increase the return on investments 10 times more according to your investments to our company, our solutions. So today's topics are, I already introduced myself. I'm going to talking about cause and effects, the relationship between cause and effects, and I will be talking about functions actually, but I'm not going to go too much deep into the mathematics and statistics. And I'm going to talk about when to use artificial intelligence, when not to use artificial intelligence, and how to integrate the artificial intelligence to our softwares. And then there will be a question and answering session at the end. Approximately, let me check my timing. It's 20 after 4 o'clock Turkish time. I will probably finish in 25 to 30 minutes. And then there will be a question and answering session at the end. And if you would like, we can turn on the mics and the cameras as well. So you can just postpone you can post your questions live if you would like also at the end. So let's start. So there's a common sense. I'm sure that you have heard about it. Every phenomenon in the world, or every output, or every effect has a cause, actually. Everything happens because of a cause. Even if you can see that cause because it's in the physical world, but sometimes you cannot see the cause because it's in the quantum world or in the universe area. So, but there's always a chaos. So what we try to do actually when trying to solve the problems of the organizations, we always try to try to build a formula like this, like y equal fx. Y is actually the effect or the output of our problems. I can give you some examples. For example, I would like to know how long this tire of my car will be working, will be turning, or uh, I would like to know why I'm having a certain tolerance problems, or I would like to know why my furnace is consuming so much energy, so much natural gas. These are our outputs, and all of those outputs all the time have a lot of causes. We can call them fx or x1, x2, x3. We are trying to, in Lean Six Sigma and in our actual operational excellence activities, we always try to find the why first, the output, and then try to find the effects that have the effect on this output. This is actually what we do. And to be able to do that, we use the logic filters of Lean Six Sigma. You can call them DMAIC, actually. You can remember them from Lean Six Sigma. In Lean Six Sigma, there are 5 phases. In the first phase, we use define. What we do in the define phase is we identify the projects and then identify the outputs and the potential inputs that has an effect on those problems. And then we use manual or sometimes digital tools, digital hardwares to be able to measure them. And then we use statistical analysis, machine learning, or data mining, and some other tools to analyze the root causes, to find out the root causes of those problems. And then we use improvements to eliminate the root causes. At the end, we take measures to keep the continuity of the improvement going on. Okay, in this webinar, I'm going to first talk about some digital tools, which actually a machine learning tool that we use in the analyze phase. And then later I will be talking about the control phase also, which kind of tools are we using to control the improvements, the continuity of the improvements. Currently, what we are living in this situation is there are vast amount of data currently in the industries. The reason behind that is there's a very big hype in the digitalization, and a lot of companies are investing on digital solutions like hardwares and softwares, and they collect vast amount of data. But with this vast amount of data, well, we started to having this problem actually around 78 years ago, and then it's increasing right now because of a lot of data, a lot of columns and rows of data. We are not capable of doing the analysis by ourselves manually using Minitab and other analysis softwares like that. But also, in the most of the time when we want to use a machine help, most of the time there are some coding experience needed to be able to do the coding and then do the machine analytics, machine learning. And also, because of the data is so much, sometimes conditional statistical analysis tools need some manual interventions, because when the data is so large, you can go to false solutions. For example, you can find out that, and let me give you a funny example. You can just predict if it's going to rain or not, just looking at your shoe size by using the data. You can find false correlations like that. That's why we need manual interventions. And one of the other problems we get actually, when we find out the solution of that y equal fx, the formula, we most in the past we were not able to integrate that formula to our machines, to our softwares. So currently what we do is we still use Minitab, as some of you may remember from Lean Six Sigma maybe, but we don't use Minitab anymore as conditional regression or ANOVA analysis. We use Predictive Analytics module of Minitab. Predictive Analytics module is a very simple tool with a very simple user interface. By just dragging and dropping and clicking and dropping data, you'll be able to do analysis very fast with a lot of data. And you don't need to code. You can just use the time and market tested data modeling tools like CART, Mars. And even with the same data, you can do the optimization. So you can have the best and less cost models as well. And by working with us, actually, we provide the support to be able to show the exact solution. So how do we do that, actually? I'm going to be able to show an example at the end, if you prefer. For example, there's a data already. This data is about heart diseases. It's a binary output data. If it says yes, then according to the predictors, as you can see, some of the predictors, continuous predictors, and the categorical predictors here, according to the data, we are trying to find if this person is at certain age, has a certain cholesterol level, coming from a certain sex, and having a certain chest pain type. This chest pain type is very important, by the way, because I have done this exercise before. According to that, we'll be able to predict if this person is going to have a heart attack or not. And for that, we have collected 1,400 rows of data. It's a lot of data. And according to that, we can do quick analysis, not only using conditional tools of statistical tools of Lean Six Sigma. We can use tools like, as you can see here, CART, Mars, TreeNet, and random forest analysis. These are already built in the Minitab version of 21. And these are all time and market tested tools, so you can rely on their results. And most of the time, we get higher R-square levels at this analysis. As you can see from here, major vessels, tau, exercise angina, and maximum heart rate has very high effects on the output of a person if he's going to get a heart attack or not. And also, you can optimize the model. You can have more inputs added to the model or not, according to your needs or according to the cost calculation you can have. Still, I have been saying this for 10 years, but still I'm saying that. In the past 10 years, I've been saying that we will be out of job. We Lean Six Sigma Master Black Belts will be out of job in 10 years. Well, this tool actually not becoming a Master Black Belt, but it's really easing our job. Still, but it needs our help to interpret the results of the analysis. But in the past, if we were spending, let's assume that we were spending 100, but now we are spending around 40. So it's 60% less time we are spending on the interpretation of the analysis. So, and after that, after the analysis phase, let's assume that we have found a solution. Let me show that on Minitab. I am resharing again my Minitab screen. Okay. Well, let me show you the data I was talking about a few minutes ago. See, as you can see on this data, at the end, these are my output data. So we have collected how many amounts of data? I thought this was 14. Sorry, it's 300 people. We have collected 300 rows of data with 14 columns of data. We have collected this data, and according to that, as you can see, we can know that if a person has a heart disease or not at the end. This is our output. We are trying to predict this output. And these are our inputs. What we do is, I just open my Predictive Analytics module. As you can see, there are different market and time-tested analytic tools. We can just select card classification. These are the data already in the model. I have did this experiment, I think, yesterday. As you can see, my response is, my output is heart disease. I just add the continuous predictors. As you can see, age is a continuous predictor, rest blood rate, cholesterol, and so on. And these are my categorical predictors. And what I do is I just click on the OK, and Minitab calculates me the best model with the misclassification cost. According to the results, I can increase the terminal nodes. Actually, terminal nodes are the these are the terminal nodes. I can just increase the results with more terminal nodes, and also I can decrease the misclassification cost and even optimize our model. As you can see, the misclassification cost is 0.41 and this is 39. Almost same, but still less, so we can prefer this one. And according to that, you can see that a decision tree type of model, as you can see, as I said before, chest pain type, if you have a chest pain type, if you have a tau disease, even if it's fixed or reversible, and if you have a chest pain type of 4, you are more likely, it's around 88% you have a heart disease. Okay, let me get back. Let us assume that we have found the best solution. And then what I'm going to do is, I will get back to, okay, let's assume that we have found the best solution, and then we have improved, and we need to be taking some measures to be able to ensure the continuity of our improvements. What we do is, actually, there's another tool called Model Ops of Minitab. The reason I have put this information here is 80% of the machine learning models cannot be implemented. I mean, you can find out the functions, you can find out the algorithms, but there's no way to integrate that information with your software. With the help of Minitab Model Ops, actually, we can deploy that model on a cloud software called Model Ops, and then we can manage it, and then we can integrate that information, that model, with a REST API, and even we can monitor it and govern it by using Model Ops. How we do that is, we can just right-click and send it to the Minitab Model Ops. On Minitab, on the Navigator tab, if you right-click on the last calculations that you had done, there's a Model Ops selection comes up, and if you can select it, and you can send that function to Model Ops. Model Ops is actually a cloud-based solution that collects and help you to deploy, remove, even move, or multiplex your models. As you can see, there are 4 models in this photo. With the use of Model Ops, we can integrate the model you have created on Minitab. By the way, it can be a simple, basic linear regression or binary logistic regression model as well. By just using that, we can, using with REST API, we can connect it, we can integrate it with your ERP, with your CRM, or SCADAs. For example, let's assume that we have found out a function, an algorithm for the energy efficiency of your steam production. We can just send that information by using a REST API to your SCADA. Or let's assume that your salespeople, by using CRM, they would like to give a pricing of a certain materials. By using our function that we have found using Minitab and by using ModelOps, we can send that pricing calculation algorithm by using the time. For example, let's assume that some effects that have effect on the pricing is if China is buying, the time of the year, the time if it's raining or not, if it's hot or not, if it's summertime or not, if it's weekend time or not, or if it's mid-break time or not. So according to that, or if it's Christmas time or Eastern time or not, according to that, the prices can change. And by using our model that we have created on Minitab, and with ModelOps, we can integrate that model with your CRM, and according to that model, your salespeople can give the right pricing to your customers. And also, we can automatically upload, deploy, even remove models using ModelOps. And as you can know, maybe from your previous experience, according to time and according to the locations, models can drift sometimes. Models need to be fine fixed after a certain time. And we always monitor our models by using ModelOps. And if things change, it will give us some alarms and warnings. So if there's an increased variability or if there's a spatial signal in the data, we can know that and we can just implement further solutions for our process. At the end, there are some also governance tools, so we can just be prepared about security, and we should be also aware about who has access to our models, who can change our models, who can use our models. So you can use the governance section of ModelOps as well. Well, these are the things that I would like to talk about today. These are our information. And our next webinar topic will be how do you increase efficiency with RPA or robotic process automation in operational excellence. Thank you for listening, and I will be happy if you have any questions. So please shoot if you have any questions. I'll be happy to answer them. Okay, there are not a lot of people, so let me turn on the microphones. So Eren Eskin has a question. Just give me 10 seconds. Okay, please go ahead.
Hi, Birdan.
Hello, Eren. How are you doing?
So, how about you?
I'm better than so. Thanks a lot for asking.
It's very nice to see you again for a long time. Indeed, I joined the conference after a while, and my question about the Minitab IDE, indeed, it's about sustainability of the models and maintenance. Let me open my cam. It's about maintenance of the models and sustainability of the models. I mean that, yeah, you highlight the models can be vulnerable, so they turn into short forms that can not answer right due to the fluctuations and slippery environment and the requirements. I mean that. So Minitab is Minitab based on a AutoML manner. I mean that AutoML. What does AutoML means? So the end users can be citizen data scientists. They have not don't have a deep knowledge in machine learning or data science algorithms, so forth. The complexity, some of the, let me say, solutions can handle the complexity of machine learning in the backend side. So the end user can easily configure set the parameters, but the complex side happens at the background. I mean that. So how about the functionality or capabilities of Minitab in this manner?
Okay, let me rephrase what I have understand from your sentences. Thanks for your question, by the way.
Welcome.
So let's assume that there's a manager. This person doesn't know anything about machine learning.
Yes.
But I understand from he or she doesn't know about machine learning is he can just, I think he can interpret the graphs, I believe.
Yes.
What else he or she doesn't know? We're not talking about statistical models here, but still there are some additional statistical data. For example, like the one we have gone through about the heart disease, we have to be going through, for example, a misclassification cost, or we have to go through some graphs actually. So those graphs can give us some information about the model, but this person doesn't have to do any calculation by him or herself. This person just by just looking at the data, just looking at the graphs, he or she can take out some of the input variables and then do the analysis from start again. Is it something you're asking? Let me show you on the example again.
Maybe let me clarify my question birden. You know, there's an exact pipeline, the solution roadmap in machine learning, data pre-processing, I mean that the clearing, transformation, or data integration, then modeling, then testing, and come up with the best model in terms of some accuracy, precision, recall, or F1 scores. I mean that. So is it possible to automate this pipeline? I mean that after a while, you know, the performance of the model will decrease below the thresholds, let me say, a critical point in terms of F1 score or recall or accuracy. I mean that after that point, after this alert, Mintap can execute this pipeline in an automated manner. Let me clarify my question. Is it possible at this suite?
Well, yes and no. Okay. There's an other application of Minitab called Minitab Connect. You can check the YouTube videos because I was talking about that, but in Turkish, I think 4 or 5 months ago. Minitab Connect actually help us because, you know, maybe, I mean, you're into, I think, data analysis. So you know that most of the time when we require data from a database, most of the time people try to write down an SQL code to be able to collect that data. Minitab Connect actually gets that data by just drag and drop, and that's it. And it's very easy. You don't need to write down SQL codes. You don't need to write down anything to enrich the data. You can just do that by Minitab Connect, and it automatically gets the newer data according to the frequency you require. So you can do that. But for machine learning, you have to do the machine learning and then send it to model ops, or model ops will give you the idea that, hey, the model is drifting actually. In the past, we were at this level, but now we're going to write. Or there's a variability increase in the model, in the data. It can give us some information, some warning signs. But you're asking if we can recreate the model automatically.
Yes.
I'm not sure about that.
Okay.
I mean, there's another application called Live Analytics on Minitab. Well, Live Analytics is actually for non-statistical managers. So that person can just look at the graphs and just by just looking at the answers, he or she can find out, hey, the reason for this problem is because of this machine is working in low temperature levels or working a high pressure level, things like that. He can do that, but if you want to create a new model, you need to redo the calculations again with Minitab.
Okay.
As far as I know, I can ask that to some of our friends on Minitab. I'm not sure. Maybe with using live analytics, we can find a solution for that, because live analytics is designed for non-statistical people, non-Six Sigma people. But let me ask.
Thank you, Birden.
Yeah, you're
I
welcome.
think seemingly the software is promising, but I will think about these features. Keep in touch.
Yes,
Bye-bye.
thanks a lot. Okay, any other questions? I guess not. So thank you for attending our webinar. Thank you for your time. If you have any questions, we'll be happy to answer them. Thanks a lot and have a good day and good evening.